Okay, we're going to look here at the concept of the average value of a function. And we're going to use the example function or the function fx equals 4x plus 2 to explain what we mean by the average value of a function. Let's consider the values of fx or the graph of fx between x equals 1 and x equals 4. So what we can see is that at x equals 1, the value of the function is 6. And then the value of the function increases as we move along from 1 to 4. The value of the function is increasing until we get to 18. So immediately what we can see is, I guess, as x increases from x equals 1 to x equals 4, the value of fx increases or changes from 6 to 18. So between 1 and 4, we have all these different values of the function. The question is, if we could write down all those values, all the values of the function between x equals 1 and x equals 4, what would their average be? What would the average of all those values of the function be? Now, we actually can't work this out exactly. We could initially make an estimate. So how we might do that is I might pick some values of the function. So I might say, okay, I'm going to use x equals 1 and the value at x equals 1 is 6. I might also try x equals 2 and the value at x equals 2 is 10. X equals 3, the value of the function is 14. And at 4, as we know, the value of the function is 18. So these four values here represent different values of the function. And we could average them out. We could say, add them together and divide by 4, and we would see that that equals 12. So that would be an estimate for the average value of the function. But we only used 4 values, 1, 2, 3, 4. So it's only an estimate at this stage. What if we were to use more values of the function? So I might stick with these ones. So here, 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 and here. So that is 18, 14, 10, and 6. And then what if I also said, oh, I wonder what happens at, say, 1.5 and 2.5 and 3.5. Let's get some more values of the function. And this would end up being 8. And this would be 12. And this one would be 16. Oops, went a bit off there. This would be 16. And I could average those out. I could add them all together. And I could divide by 7. And actually what I would also get, again, is 12. So conceptually, this is what we're talking about with the average value of a function. It's the average value that the function has between two certain x values. Now, the problem with doing it this way is that there's no end to how many values of the function we could use. We could break this up again and use, 1.25, 1.75, 2.25, 2.75. So we could use those values of the function. We could go even further, and if we think about, there is an infinite number. There is an infinite number of x values we could substitute in, and therefore an infinite number of values of the function. So luckily, we have an approach to this where we can use integration to find the average value. And we have a rule. So here's our rule. The average value of a function over the interval a to b. So we're always interested in the average value of a function between two x values, between 2 points. And we integrate the function between those terminals, a and b, and then we multiply that definite integral by a fraction, by 1 over b minus a. So let's look at how this technique works for the example we've just been working on. The average value, so here's my function, here's a, and here's b. So the formula is 1 over b minus a, ba fx dx. Okay, so we're going to sub in 4 for b and 1 for a. The terminals are 4 and 1. The function is 4x plus 2 with respect to x. And let's work this through. 1/3, we'll do the integration now. The integral of 4x will be 2x squared plus 2x between 4 and 1. Let's go a little bit further down. Now I'll evaluate the definite integral by substituting in, firstly, 4 minus, and now I'm going to substitute 1 in. I think I've got enough brackets here. No, I need one more. Okay, let's do some evaluating. 4 squared is 16, times 2 is 32. 32 plus 8 is 40. Minus, this is 2, and this is 2, so 4. 1/3 times 36, which actually is 12. So our estimating approach that we used earlier actually got us the right answer. But that only worked because of the nature of the function. It was a linear function. It was increasing at a constant rate. If you try to do that approach with a quadratic or an exponential or a trig graph or anything else that actually curves, it's not going to work. We could still estimate, but the way to work out the average value is actually by using this formula that we've just looked at. So let's try one more example. Find the average value of y equals 3 on x squared over this interval, 1 to 4. Okay, so the average value will be 1 over 4 minus 1. So I've gone with 4 and 1 again. I'm going to rewrite this before I integrate it. Okay, and now let's integrate. Increase the power by 1 and divide by the new power. And to make that a bit easier for myself, let's go, let's call that negative 3 on x between 4 and 1. So it's 1/3. And now we're going to sub in negative 3 on 4 minus negative 3 on 1. One-third, negative 3 on 4 plus 3. I'm really labouring this out, but let's just get this right. 3 minus 3/4 is 9/4. 1/3 of 9/4 is 3/4. So this is the average value of that function. And if we think about a graph briefly, we're talking about the function here, 3 on x squared. It's a truncus that looks something like this. If I have a closer look at this function in this interval that I'm interested in, I'm interested in the average value of this function between x equals 1 and x equals 4. So at x equals 1, let's use some function notation. At x equals 1, the value of the function is 3. At x equals 4, the value of the function is 3 on 4 squared, 3 on 16. So we can see that as we move along this interval, the value of the function is going from 3 down to 3 over 16. It's assuming all of these little green values in here. So if I were to average those out, the average value of the function across that time would be 3/4.